But hello, everyone. Thank you so much for joining our first webinar of the year. We're very glad to see so many familiar faces as well as new people. So I'm Doruk, part of the team here at TuringDB. I'll be the host slash moderator for today's discussion. Quick disclaimer, like we mentioned in the chat, this session will be recorded. We actually had quite a few people who wanted to join from Australia, but apparently it's 4 a.m. in Sydney. So if anyone from Australia actually made it live, we appreciate the dedication. We'll have a link at the end of the session for the recording if anyone here also wants to access it. So for today's agenda, we'll start off with some brief introductions to our speakers, and we'll have a very brief context on why AI needs connected data, some very brief overview on graphs, and then we'll introduce ourselves, what we're doing, who we are, a little bit on that, and then we'll move on to the main discussion part. For today's speakers, we have two of our founders, Adam Amara and Remy Boutonnet. And then we also have Sergey from Wolters Kluwer. We're very happy to have him here today with us. He's leading the graph technology team there. He's mainly focusing on GraphRAG solutions, connecting knowledge graphs with LLMs. He's also one of the most iconic members of the graph community. So we're very happy to have him here with us. And with that said, I'll hand it over to Adam to take over.
Yeah. Thank you, Doruk. So we're going to cover quickly, I think, of why we want to talk about connected data and for the people that are more familiar with graphs more fundamentally, you can go to the next slide, Doruk. That's the usual spiel, connections, turn data into intelligence. I think a lot of people in the group are already convinced by the aspect of connecting information with each other is what helps us make sense of things. So next slide, Doruk. So I think the first point that I want to bring in quickly is graphs come in many shapes. So whether it is to keep knowledge, to store knowledge, or to try and represent the real world in an extent, so digital twins. So really going from knowledge graph data storage to digital twins, we want to touch a bit to those different points because each of these have their own specificities in the space of graphs. And one thing, one disclaimer in that aspect, especially knowledge graph and data storage people are going to come RDF, not RDF, LPG, etc. That's not the debate we are coming into today. We are LPG people. That's obvious from our DB, and I think there's plenty of very good resources and better people than me and than us to an extent to maybe speak about RDF if they want to. But here we're really going to speak about clear application we've seen in our life, in our work. So Sergey will share his view as an enterprise for us as a company in the space as well. Next slide, Doruk. One thing that's really interesting in the last few years with graph databases and graph technologies has been that they've kind of have shown up everywhere in the AI space. So I think the general points that give you some ideas to go search around is whether it is in the GNN space, it's been there for a wee while now. GraphRAG, reasoning, neurosymbolic AI are becoming kind of hyped as well the last few months, a year. But I think there's also so much more interesting things in the digital twin space, graph analytics. Nowadays, also in the other hype subject, agent orchestration and agent work, we start seeing more and more of those graph applications. So whether it is to learn from entities, connection, when we talk about machine learning, or simply preserving the structure and connecting the information. So we believe a lot in the very simple searching data. And indeed, as Max say, agentic memory is coming as a big thing to there because, again, you are connecting those knowledge, those information, so it can be retrieved by those systems. So in the end, all in all, I think that the core of it is about representing complexity and getting access to that complexity in a form. Next slide, Doruk. So just to give a good overview of the thing that we hear a lot in the graph space nowadays is obviously how do we get unstructured data, and this has been opened up by all the changes around the LLM and agentic space nowadays. So people that worked in NLP, in entity recognition have been obviously working on those things for a while, but now a lot of things have been unlocked thanks to LLMs. And obviously, we are starting to see those unstructured data coming from documents, etc., entering into graphs. And that's where, so I'm sure some RDF people will come and talk about ontologies and stuff. And here we want to look a bit at how can people get kick-started, and then how can you go build all the way to production things that can just make sense for the people on the ground, let's say, without having to build an entire large-scale enterprise piece there necessarily. Next slide, Doruk. Yeah, just wanted to share something about our origin. So actually, Remy, who's my co-founder here, we are childhood friends. So we used to dabble in the science club of our tiny town in the south of France. So that's how we got to know each other. And about like good 10, 15 years later, we decided to kick off actually by building Turing Biosystems initially, where we used and built graphs for biological digital twins. And we worked with companies like Sanofi, Roche, and so on, trying to understand what are the interaction in biological systems that could lead to better drugs, to better treatment for patients. And one thing we realized, and also in my past life when I worked at WHO, I deployed graphs at scale. I worked with stuff like Neo4j and others, and I was very much frustrated by the state of the technology in place. So we ended up building our own graph database engine that now became TuringDB, because we're going from molecules to markets, as we like to say, and basically trying to tackle some very specific problem of latency, of multi-hop, deep traversal, and thank you, perfect timing, Doruk. Basically, those real problem that we faced ourselves. That's why we built it. And aspects of auditability were really important because we worked in regulated industries. So obviously being able to trace back what has been changed, when, by whom, can I go back in time travel, fix that, which helps us with maintenance. And eventually also some stuff that we're obsessed with beyond the performance, also in memory efficiency and aspect of using those things in memory. Remy, with his chip design and software engineering backgrounds, can attest of that. And yeah, I think you can go quickly to the next slide.
Yeah, I mean, this was pretty much it
That
for
was
the
it,
brief
yeah.
context.
Perfect.
We can start the main discussion part. I'll quickly unmute Sergey and Remy. Hi, Remy. Hi, Sergey. Welcome back. So we'll start off a bit more general, and then we'll go deeper into the technicals as we go on. So I first wanted to talk a bit about the evolution of graphs and how all three of you experienced this throughout, your work. We've seen graphs come off as, some R&D experiments, more proof of concepts, now moving into actual production systems. So I was going to ask, what does that process look like? What are some main things that push a graph technology from being an experiment to an actual production systems? Let's start with Sergey.
Well, yeah, thank you very much. So, yeah, I'm representing the huge company, Wolters Kluwer. It's really a big one, and it's have their specialization on their data and information services. So we're manipulating with their terabytes of data. It's kind of how we're practicing in a day. And honestly, we are with the graph plenty of time already. So if I'm counting it correctly, it will be more than 7 years, even longer. So at this moment, we have their, I would say, storage graphs in the capacity more than kind of 5 terabytes. It's okay for us, where we store a lot of information for the legal domain, for the health domain. But that was correctly mentioned that there is a shift of their understanding what the graph is for. And it's also happening in Wolters Kluwer, and we actually participating with that the graph is not only the static knowledge, it's not only the kind of the classical representations of their data that can be queried, but also the knowledge that have to be actively participate in the interaction. And that's kind of the shift in the mindset is not that easy. So AI is definitely pushing it ahead because it's always have theirs as a part. But my personal practicing is that we always have to be explaining why we need GraphRAG, for example, in compare with the RAG. So that's our continuous discussions with the business. I don't know if Remy or Adam have this kind of their conversations, but this is our daily business. So we have to explain that with their GraphRAG, RAG is good. We have to admit, RAG is kind of good on its position, but there is a situation like a point in time of the facts or the traceability of the facts when it can't reach the quality that business accepts. So that is where we step forward and say, hey, we have to creating the combinations of their knowledge exist or the new one together with the RAG that exists, because there is millions of documents have been vectorized. But now the question is how to bring that vectorized pool to be connected with their factual information that actually bring the limit to the AI to hallucinate in the moment of the LLM processing the questions or answers based on the questions.
Great. And coming to Adam and Remy, in more like regulated spaces like healthcare, for Adam, it would be cancer research, Remy, chip design, defense, these kind of things. Where does that bottleneck usually come from? Do you think it's operational complexity? Is it the infrastructure? Is it the regulations of using these new technologies? What usually happens in that scenario?
Yeah, I think to give my 2 cents on the healthcare side. So yeah, I think first thing was obviously the kind of regulation you need. So if you talk about AI and LLMs and so on, it's all great, but one key problem we had when we tried to deploy, notably, when I was at WHO, we would try to deploy graphs combined with different AI models. So LLM were not as advanced when I was there, and ML models were running left and right. One core problem was first accessing the data, allowing the data to be somewhere, and then making sure that it's fully controlled. So that aspect of governance and auditability and all those aspects had to be clear. And the problem with graphs at the time, what I had under my hand being Neo4j and a few others that I had played with, but that was main one, they did not allow you that flexibility of being able to really, or you had to build a massive application layer around it, and then your latency becomes horrible because if you go and query anything that's like more than 3 or 4 hops, it starts taking time. And in healthcare, any queries is factually most of the time 3 to 4 or 5 hops. If your symptom is connected to a disease, it's going to take not just 1 hop in general. And so these kind of problems, we kept seeing them again and again. So things were too slow. No clinician or researcher wanted to use the app because it took literally like one stuff we had developed, like the outputs of the graphs would take like 2 hours, 3 hours. Some other more exotic stuff literally took days. So it was just not tractable for us at the time. So that's kind of one problem we've seen, is basically having both that governance and architecture problem. And Remy, I'm sure you have more in-depth stuff there.
Yeah, so I was very privileged in a sense because I come from the chip design industry and especially CAD, computer-assisted design of chips. And a chip is naturally a graph, right? Because even if you look at the electrical installation of your flat or your house, it's naturally boxes related by wires. So it's naturally a graph in a sense. And if you look at the chip you have in your iPhone or in your laptop, it's naturally a graph of billions of components. So let's say since the 1980s, there is no serious way of designing these beasts without doing a graph in a sense or another. So I come in chip design from a community that was using graphs from the start. So to me, graphs were the natural way of seeing the world. It's the natural thing for me. And that's why also I talked to Adam and I was glad to see what's happening in healthcare, because I come from the world where graphs were the status quo, if you wish. Nobody represents, I mean, nobody serious represents chips in a relational database as stable. What does it mean? I don't know. You could potentially, if you can't sleep at night. But, you know, for me, I come from the standpoint where graphs is a natural thing. And then we went to these industries like pharma, as Adam says, where, okay, in bioresearch, graphs make sense. It's just that, as Adam said, sometimes it's untractable, at least with Neo4j it was. So to me, it was all very natural to me.
Mm-hmm. All right. And let's talk a bit more about industry-specific aspects. Like one side, like I mentioned, I know defense and pharma, these are all very relational, you know, naturally interconnected spaces. And they always come to mind as a bit slower moving, a bit more, you know, regulation heavy industries. So what do you think will change in the upcoming years with, you know, everyone's trying to adopt AI, everyone's trying to utilize this big data that they have, but what do you think is going to make them, you know, push forward into production? Like, what do you think the limitations they have with the current state, and what are the potentials if they actually utilize what they have?
So to give from what we see, so generally speaking, so there is a lot of POCs out there, you know, like a lot of people do little POCs left and right, etc., you know, on many subjects around graph, combined with LLMs doing stuff, or just graphs alone. So like, you know, you do a small knowledge graph and then ends up being unused because there is no, you know, useful interactions with it. There is no truly, like no one truly thought of how people would, the end user would go and use it. Because when you go talk to a clinical researchers, they don't care about a graph. They want to know what's the clinical outcome. You know, when you go to a pharma, like in the end, what they want is their assets to reach clinic. So they don't care about the graph. It needs to allow something. And I think for it to go to production is to have people that are really internally within those companies capable to drive, you know, like an understanding of product development factually, like understand what's happening there and what do I need to go deliver. And the second piece in terms of production is having something as simple as possible at first with a high impact. So in biology, one thing that had high impact quite quickly, like I would say 8 years ago, is drug repurposing. Very quickly, they say, okay, if I start connecting my drug to all the targets and all the knowledge, so basically a knowledge graph, and start search that knowledge graph and see what other drugs could go and hit something similar. I could repurpose a drug that's out of patents. That's a clear business outcome. And now we see that so we've now moving into production in other subjects, whether it is supply chain, manufacturing. Okay, now I want to go push my drug. My vaccine is going to market in about 2 years. What are all the things I need within my supply chain? What could be a blocker? It's factually also a graph, and you want to go and start asking questions and search, okay, is this supplier safe? Is it is the EU gonna approve this supplier? Does the US gonna approve this supplier, etc., etc.? So this kind of stuff are starting to move to production, but it requires clearly mapping a need to an architecture, not start with the architecture and push on the need, let's say.
Yeah. And Sergey, how does it compare to what you're seeing with Wolters Kluwer over the years?
Well, I would like just to mentioning not only Wolters Kluwer, because Wolters Kluwer is kind of their document and their financial processing oriented the company. But due to my contact with the enterprise, I would like just to mention their huge elephant in the room. There is a kind of the company like Oracle who actually pioneering by the graph interfaces. So it's one of the main contributors to the GQL standard. It's kind of the standard that I believe we will just end it with. There is an interesting experiment calling Apache Age, something like graph interface above their Postgres. And we have to admit this amount of data that these databases are hosting in enterprise in production is enormous. And there is a big demand to integrate that with the GraphRAG solutions. And here is where I see the big demand on how this information can be kind of put on top to be visible for the AI layer. So I can say there is we talk about the graph, but we graph people. We're talking about graph engines, but we also have to remember that there is a lot of data that can be presented as a graph, but it's not maybe storing in the graph at this moment. So
Exactly. Yeah. And Remy, maybe you can give a couple of cents on like your experiences with both chip design, defense, telecom networks, which are, like I said, naturally interconnected systems.
Yeah, so we speak a lot about graphs. So there is the of graphs as knowledge graphs. Okay, so we understand. I mean, most of you understand, I think, what is a knowledge graph. Okay, so you have entities where, for example, on Amazon you may have items like you have a chair, you have a table, and then you could relate your table, or at IKEA, whatever you like, really, which relates the table to its material. It is a table which has a material wood. It is painted in blue or not painted at all. So you represent as a graph with entities related to a certain number of information or properties, what you know about that set of entities, what you know about that domain of knowledge. That's what the graph community, I think, understand a lot. That's also, funnily, what focuses on also everybody talking about ontologies, because, okay, a table, it's fair to say that a table is actually an object I can find in my kitchen or my living room, but anyway, it has a place in someone's apartment or flat, right? Which is completely different from heavy industry equipment that normally you won't have in your house. I mean, normally. So there is a sense of hierarchy and ontology which arises naturally when we want to organize knowledge into knowledge graphs. But then there is an entirely different class of graphs. I forgot actually the one Sergey is mainly dealing with, which is graphs extracted out of documents, which may actually be knowledge graphs, but we may imagine a number of graphs out of documents. For example, if we want to have documents as nodes and edges between nodes being co-occurrence, meaning I can see different entities or different persons appearing in the same document, for example, that may be useful. But that's, let's say, I would put them in the bucket a bit closer to the knowledge graph application. But there is, to me, in the industrial domains, in what I've seen in computer-assisted design, chip design, which is using a graph as a representation of the world, as a digital twin, we say these days. But, in a chip, at the end of the day, you have a node, which is really a logic gate, an electronic component that if it's at the scale of your house, it can be a switch or a light bulb or something you can touch with your hand. If it's in your iPhone, well, it's something you could touch with your hand if you had a microscope. But it's a thing that has a physicality that represents an object that really exists in the world. Because in a knowledge graph, if I speak about, I don't know, let's say a knowledge graph about drugs for kidney disease, for example, I can touch certain parts of the kidney. Well, now it starts to be a bit gruesome, but let's say there are biological processes, or I can know as a pharma company certain things in theory about what's happening in the liver, but these are processes or these are abstract information. This is not always in a knowledge graph things that have a real physicality that I can touch because they are independent objects in the world. Where in a chip, we have resistors, we have components, we have things that are really objects in the world. If I am representing a factory, for example, in all these things, talking about Factory 4.0 or Industry 4.0, where it's about, can I represent a digitalized factory as having assembly lines with machines and workshops and people transmitting pieces from one machine to another. Those machines can be nodes in my graph, and those machines exist really in the world. So this is what a digital twin is. It's not just to represent things that could be belonging to ontologies, as all the RDF community likes to say, but to me, a graph is first and foremost a thing that was invented to represent the world, objects in the world, like in a chip, like in a factory, and how they are transmitting either current, either goods, either processes or energy or whatever between them. This is, I think, for me, really interesting applications of what graphs are in the industrial space in general.
And building on
There's
top of
always
that, go ahead, Sergey.
So just one comment to Remy is just there's always interesting aspect when the data in graph become the knowledge. So this is kind of the interesting transitions on the kind of the reflecting the digital twin of the real life to becoming kind of their semantical level of for their any AI or agent processing, and that is kind of the very very important to understand the conditions and criteria. So.
Yeah. I was actually building on top of my last question before we move on to the next section. I'm sure all of you will have opinionated ideas on this, but I was going to ask, what do you think our graphs are genuinely good at in today's world, and what are some areas that are being highly oversold at the moment? Let's start with Adam.
Yeah, I mean, as generally speaking, in terms of graphs, what I would say is, as Sergey mentioned, for example, with the case of Oracle, you have your data there. You need a representation of top, so you can use graphs as a mental model, a representation. So anything that's like 1 or 2 hop, meaning like could be so. That's where I need to do a distinction between graphs and graph databases and graph technologies, because there is the aspect of graph as a way to think, which is, I think, amazing, works everywhere, should be applied everywhere. And then graph databases, which shouldn't be applied everywhere and don't work everywhere. So the thing there is, for example, if you think of, okay, I just want to do 1 or 2 hop max, so 1 or 2 joins, most of the time, it will do the job to do it in, whether it is an abstraction on top of Oracle that just, show you a nice visualization of your thing connected to another person done. That's cool. It's a nice little visualization. Or you want to run in PostgreSQL a couple of join. That's good enough. That does the job. You don't need necessarily to go for a full-blown GraphDB. Now, where it's really, really important, it's when you start looking at really complex stuff. So you start looking at complex interaction like traversals. Good luck doing that with any tabular data, including something put on top of an Oracle DB or anything that's stored in traditional RDBMS. If you start looking for 10 hops or something, so I'm thinking of processes that Remy mentioned, whether it's supply chain or manufacturing, your plants breaking down maybe something due 10 up, like 10 nodes up, because your supply did not arrive from Taiwan in time. And so your manufacturing stuff is stopped down the line and it costs you 500K per day because your plant is waiting for the supply to come back and reswitch, and then et cetera, et cetera. So these are real life cases we've seen. And so I think this is typically where the graph makes us a lot of sense, like this kind of multi-hop search, and obviously like allowing nowadays, I think, and Sergey can also can talk about these things, I imagine too, but allowing agentic systems to explore graphs is also a great way nowadays to basically push further. Those connections can be really literally explored by agentic system and new LLM models. But yeah.
Yep. Sergey and Remy, any points on that?
Yeah, I will just bring the classical academic rule of the 7 joins. So if there is a 7 joins in the relational database, you're dead. So this is where the kind of their graph will shine. So the graph will always shine where there are relations. There is a relations between the entities, even if they are simplistic, but they're can be easily be modeled and whiteboarded and then just mapped to the graph. This is the way to go, and this is exactly how the other mentioned directly connections to their AI world, because you have to explain the same model to the AI in more logical and structural. This model way easier will be can work with any agentic flow. So there is a storage. There always will be a storage. Enterprise will always request the storage of the terabytes of their tabular data. There is a knowledge or connected knowledge that may be huge, may be small, but it's as Adam correctly said, there's kind of hopes will just save your kind of the problem in the logistics. Hopes will save your problem, for example, in the legal world, where kind of the case that was opening in one court appealed and then was reviewed, and there's very hard to make their direct connections between the two documents through this kind of the legal process. So there always will be the case when we need graph representations of this world.
All right, so that's a great point to move on to our next discussion point, which is graphs in the age of agentic AI. So obviously I'm sure everyone's aware, there's a lot of discussion about, context graphs, context engineering for agents orchestration. So let's settle this once and for all. What's the main difference between knowledge graph and context graph? And what do you think the aspect of context graphs is currently missing, what they're good at? Where do you think this will evolve? Let's start with Sergey, because I know he's very into this topic.
Well, I'm into this topic with the position that I have my arguments against the context graph definition that now actually very promoting by the different vendors, and they're trying to sell it as a kind of another presentation to the businesses as a solutioning their problem. So we all aware that the knowledge graph is representing kind of the information. If you are adding there the temporal components, requesting that this information is valid in that period of time and becoming the context, it's not becoming something new that didn't exist in the past. We always were kind of there in the complex system. We're always looking in the kind of time framing or the time intervals for the validity, for the any other elements that just coming with the time. And the context is always changing. So that's why when we're talking with LLM, we're always sending the new context to the LLM to process. It's for me, it's a new buzzword. My apology, maybe it's just too direct. So there is a plenty of the different elements of the knowledge graph, but we'll do exploratory work further, and we'll finding in other ways like lexical graph, there's semantic graph, and other graph. Context graph is a new interesting name that I will believe will go soon away, and we'll just be back just to fighting with the new buzzwords that will come with the vendors, because they have to kind of catch attentions of the business to something new. Even this is just the wrapper of what we already exist with additional explanations. That's my opinion.
All right, so we're getting a few questions in the chat, but everyone will have an open discussion and Q&A section at the end. So please save your questions by then. You feel free to send them through the chat or unmute yourself when it's time. Yeah, Adam, what's your take on that? What do you think? It's obviously very popular. Every time you go on LinkedIn or whatever, this topic of context graphs is going all around. But isn't it mainly just context engineering, decorated with the word graphs and then trying to, what do you think?
I think, I agree with Sergey. It's a buzzword that kind of try to throw a lot of things inside, but there is some nuggets of truth under it. Like it's at least bringing out some stuff. So I do agree. Like in the context aspect, for example, we've seen many stuff that could be considered as what they would like to call context graph, but basically, context engineering with graphs. So you are feeding paths that are extracted from the graph, subgraphs that have some kind of reasoning associated. And I think Remy also can probably talk quite a bit on that, because he comes also from a reasoning and symbolic and background initially. So I'm sure you can talk about the automated reasoning aspect also in that space. But
so my experience was symbolic AI, in the sense of the good old logic-based trying to reason using logic rules and deterministic systems way before LLMs. So that was what I was doing during my PhD, and we didn't have LLMs or context graphs at the time. So an entirely different set of technologies, but basically. So it's by the way, these things are used a lot in a lot of defense applications, a lot of safety critical applications where things that you would trust your life with. So even in avionics application, when you take a plane you want the plane to work at all time in all possible scenarios. You don't want to be like, GPT 4.0 decided to, maybe not reason as thoroughly as it could this morning. And so maybe I have an interesting detail in my plane that it overlooked, and guess what? The plane can crash. So it's not this kind of reasoning. It's the kind of reasoning where it's either true or it's either not in the mathematical sense. Not the I'm reasoning, kind of. It's there is reasoning, as I like to say, there is a reasoning for making a recipe in your kitchen, where if it's slightly wrong, the recipe, you don't really care because worst case, it's a dinner that is lost. And then there is a reasoning for defense, for critical industries, for any kind of thing where you want to assess, can I have bugs in my system? Can I have terrible things that can happen? So this is a different type of reasoning, and in these kind of things, in all these kind of safety critical systems. So again, software control of airplanes, all these systems controlling airplanes, nuclear reactors, or all types of defense applications. People do meetings and want to see traces or paths in graphs of, okay, if the pilot in my plane is pushing this lever and pushing these and these buttons, or attempting this and this maneuver to actually maybe bring the plane down or something, they want to see, okay, what is likely to happen from the action of pushing the lever or pushing a button in my plane to, okay, there is an onboard computer that will take these and these decisions. And then in the end, it will govern the plane in different ways to actually bring it down or not. And so all these things are regularly examined, were first seen and studied by human reviewers if you're working at Airbus or Boeing, but now using reasoning tools and the deterministic ones, not necessarily LLM. So all that to say is that there is a long industrial practice of examining graphs, examining paths of what may happen in systems, seeing systems as graphs, and also a posteriori, if we see a bug, if we see something that exploded in my plant or in my system, I may want to do root cause analysis, which is okay, whether it's something that blowed up in my factory, or if I am a telecom company, suddenly half the country is not connected to the internet anymore, can't pass phone calls. Maybe it's because I have a very subtle misconfiguration in my telecom network, or some telecom switches that were not configured in the right way, And all these things are usually very subtle, and it's really great to see them in graphs where you can, for example, mark in red the components that were faulty and see basically what went wrong.
Mm-hmm. Yeah, and we had a message in the chat at the beginning of the call. That was actually one of the things I wanted to mention. What do you think about graphs becoming like a shared memory layer for, agents? Do you think, what do you think about that? Does that bring a new type of system requirement on how to, architecture certain things? What do you think about that? Let's start with Adam, for example.
I think on that front, from a pure graph architecture perspective, I don't think there's necessarily, because again, like memory is a big word. I think you can see like in the agentic space, some people call memory just a text file, So, let's call a cat and a dog. So if you want your graph database to be a memory and you store that in a graph, it can become memory. It's just about how you think about it. Now, the really interesting aspect is the behavior within the system. So a text is never going to be dynamic. It's never going to be, so if we go down to the RDBMS structure, people are using Redis, which is a really good low latency relational DB, but it's not meant to store things, that are necessarily connected, but it's going to be really good to retrieve things quickly for your agent. It can try to think on it. Now, if you have graph databases, graph infrastructures that are properly set up, they can serve a dual purpose. I'm storing information, just like what Remy mentioned. For example, I'm representing my company plant and infrastructure there. I know how to track things. I can combine my, let's say, more logical management of things. We don't need to put LLMs everywhere. We can have good old logic into things that deserve it. And then you could have an LLM layer on top. And this could be treated as memory, meaning what happened in my plant last year? Why is this production level did not reach 1,000 units by midnight? We expected that. Your LLM can go and analyze your graph and be like, well, from after searching and querying my graph, I may see that actually that area in the plant has shut down last night because the guys were not present, or the electricity dropped, or whatever. So this kind of stuff, that's where I see this kind of layer happening, having that dual aspect. But yeah, I don't know, Sergey, you probably have also your own.
Well, just to be honest, when we're talking about their memory for the agentic flow, we just on the technical level, we just allowed agents to write back to database. Normally, agents is only reading. So the memory is meaning that it's producing something back to the database, and then how it's producing, it's a big question. Is it we giving the total free because the graph database is schemaless, so you can write whatever they want, and then they're just finding out what's their schema they created, or we just prescribe that, okay, you can write only about these entities, about this information, and then, as it was correctly mentioned, the text document is actually very close to the same because it's a very predefined structure. So it's a very interesting kind of level of the communications with the LLM, because before that we're only sending back to LLM the context and say, hey, LLM, just execute that. But now we allow, say, LLM to react back, and honestly, it will be interesting to observe how it's going further. LLM is becoming more smarter, but hallucination is still with us. It's a feature, it's not a bug. So you always have to create the memory, hallucinated, restricted. So we try just to be sure that whatever is coming from LLM will not be something strange. In my world, in the Wolters Kluwer, because we are servicing the legal cases, health cases, you can't store the fictional court case, because LLM can produce them, then we will store it, and then we'll start reusing that. And that could be ended with their huge fees or penalties, because they're just coming with the wrong facts. So memory is a power, because we're just giving the power just to be dynamic. Memory is a weakness, because then we have to monitor what is in the memory.
Exactly. And coming to the final point regarding graphs with agents, I'm sure Sergey loves this topic. At what point do you think it makes sense to switch from RAG to GraphRAG? Because everyone's trying to implement GraphRAG, but when do you think it actually makes sense to switch to GraphRAG? And what are like the difficulties in building one, maintaining one, actually getting valuable and retrieving valuable information from your database?
If I can start, then I will say, well, we all working in the restricted areas of businesses. So because Wolters Kluwer is health, legal, financial, their RAG by itself is a nice tool, but it's too flexible for that. In my world, GraphRAG is mostly prescribed. You can't rely on the answer from LLM without vector stability or repeatability of the question. We did internal experiments, and we see that if you ask 3 times the same questions only to LLM, even the latest very advanced model, it can come with a very interesting nuances that you never just having that before. So what will be my kind of payment for my financial act that was I reported 2 years back, and then answer could be interestingly surprised. So because it has no traceability back, the same in the health, it's becoming the critical for their doctors to make their decisions. It's for finance, it's even just the same. You have their huge penalties. So you have to look what's their the business goal. If you have just nice chat conversations with the agent and some kind of their fluent way, it's always nice. But if you would like to have their precise answer that will be not changed from their iterations to iterations, then the facts in their connected way is the way to go.
Mm-hmm. Mm-hmm. And Adam and Remy, do you have any points to add on top of that?
Remy, I don't know if you had something.
Yeah, I think uh, I agree with everything that Sergey said. I think what we have to remember with RAG in the sense of classical RAG of, okay, you have a question in natural language that you are you are submitting it to an embedding model that gives you an embedding vector corresponding to that question, and then you are submitting that vector to a vector database, which returns you the n being n equal to 10, for example, the 10 most relevant documents around the point of that question in your vector database. To me, there is a lot of ifs first and foremost behind it, which is you have it relies on the entire premise that the model is good enough in the sense that the documents that are close enough semantically for your domain, for your definition of being close to each other in terms of meaning, are close to each other in the embedding space. Meaning that if I will submit the query vector to my vector database, the n nearest most documents will actually, in the embedding space, will actually be the n most interesting documents from a human point of view, from a domain-specific point of view, to my question. This may be the case. We may hope that it's almost always the case if embedding models become more and more sophisticated. But as we know, in a lot of complicated industries, and for example, in healthcare, the questions are never simple. It's an evidence, but if it's a question, for example, asking about a process, for example, what drug should I give to a patient to remove that eczema or that nasty rash they have on their skin? It may not be a document which is directly related to eczema or the rash. It may be something which is in fact related to a process that went wrong in their liver or in their kidney, which is in fact very, very indirectly related to having a rash, just because the kidney or the liver just releases some bad toxin or something. So it's in complicated applications, it's rarely about, it's nearly never always about the strict semantic similarity of documents, but something that may be connected way, way down the line. So to me, that calls more to GraphRAG, I would say, in that sense.
Mm-hmm. Yes, perfect. Thanks so much, Remy. And we'll move on to our final topic of the day, which is modeling reality with graphs. What do we mean by that? We mean digital twins. The digital twin world is going in like all kinds of different directions, trying to digitalize organizations, companies, systems. Well, let's go back to the most primitive, or not primitive, but the origin of digital twins, trying to digitalize manufacturing processes, like telecom networks, biological systems. What makes graphs, which is a very general question, but what do you think that makes graphs such a obvious fit to model these kind of systems, and what makes them much more advantageous compared to other traditional data models, allowing them to do things that weren't possible before? Let's start with Adam, maybe touching a bit on the pharma and computational biology space, and then we can go on to the manufacturing processes with Remy and Sergey as well.
Yeah, I think we touched multiple times during the conversation. I think on the subjects in the end, but not to repeat myself. But I would say probably the core piece there on the digital twins is, if we go back to the basics, is as Remy said, representing the reality. So whether it's a chip, whether it's a plant, and for us in biology, it was, for example, try to represent a patient group, a population, as a digital twin, and start asking questions to that system factually. So start simulating things on it. That's also the purpose, and then changing over time. So it has to be a dynamic system. So obviously, first, a graph makes sense if it's able to store the relationships, those complexities. And then another aspect is, I'm coming from a label property graph space. You can work with the labels a lot. So you can start creating spaces of nodes and edges, being okay, these edges and and nodes are part of this label, and you can query it, and it literally creates your subgraph immediately that you can start limiting your digital twin area, because a factory may be 10 buildings. So you may want to just query one building. So you just take the nodes associated to label linked to that building. Same for an organ, this kind of aspects. And then that second component being the temporality, spatiality and temporality. So in biology, we've seen things on tumor where we presented them as graph. So over time, a drug may dissipate into the tissue, and that tissue also has a spatiality. So these are the kind of information that can be stored in the graph as well. It requires some tricks, but it's very much feasible. And I think now it's kind of merging. I mentioned that with the LLM approach, where it starts getting interesting is like starting to interact with these as system of knowledge, let's say, but in a different way than knowledge graph, meaning, okay, it may interact. Oh, did this patient group why did this patient group have a side effect? And now you've put in place your whole system and be like, okay, I'm going to go query the side effects in this patient group, try to search within the graph, maybe kick up some basic query already in place, and you start having, a dynamic system there. But yeah, that's kind of what we see coming, what people are starting to build with us in that space, and that's quite exciting. I find that's more exciting than chatbots, but yeah, it's my to say.
And Remy?
Yeah, I do agree. I touched upon it many times, but reality, we can see reality with graphs because reality is entities and interactions. And there is, as Adam said, I think also there is something which is frequently overlooked when we talk strictly about knowledge graphs is nodes can be active, So it's evident when a node can be a factory or a room in a plant or something where a place where something happens because, I may assemble something with iron, and then there is an output of that workshop that goes into the room where the final assembly of the shiny thing happens. So there is a node where something is produced, which is my pieces of iron, and then there is maybe a conveyor belt or a truck that gets it to the final assembly room. So it's not like the table in IKEA knowledge graph anymore. It's really nodes that are active where things happen. And in a chip, in a circuit, in your house, it's obviously active when you push a switch to switch the light bulb of your living room. The light bulb is active, right? Because there is electricity that goes through the wires from the switch to the light bulb. And so that's the thing which is really interesting, especially if we also, for example, in finance, if we want to look at things about risks or different entities that may have different roles in markets, all of this is about activity and not just things that represent categories or abstract information.
All right. Sergey, do you have any points to add on that, or should we move on to the Q&A section?
No, just 2 words. That's actually the digital twins is a very specific graph modeling practicing. So I will not mixing with their kind of other things. And as we hear their LPG practitioners, I would say I'm always fascinating that how information can be stored in the edges. We can do their mostly unlimited number of edges between their entities by describing different aspects of the exceptions or whatever, plus the properties on the edges that also giving you flexibility. That's my daily practicing. And yeah, I can say this is a very interesting topic, but it's not 42 minutes. It have to be way dedicated to discussion.
Yeah. So to tie everything all together across all the 3 points that we mentioned, so scaling, moving from R&D to POC to production, agentic AI, and digital twins, what do you think is the next big problem or not next big challenge for graphs in the upcoming years? And then we'll slowly move into the Q&A section as well. If anyone has a question, feel free to raise your hand while Adam, Sergey, and Remy answer this last question.
Sergey, go for it first, and then you're the guest.
Thank you. So I think that's the biggest challenge in my vision is still kind of the correct integrations and they're understanding the role of the graph in the AI world. So what is the data? What is the knowledge graph? What is the knowledge graph and how it's actually integrating with their agents? Is it memory or it's just the source of the context? The challenge that we have just to go through this year for sure is to stabilize this because LLM becomes smarter. The theory of the graph becomes more powerful. As I see a lot of kind of improvements there and on the different vendors, and it's really, really giving a feeling that we are on the right direction. So,
Adam and Remy?
On my side, I would say probably the making graphs basically feel like they're not there. Very simply. So in the sense where you don't know when you are running on a relational database in the background of your app that you are using, but you are getting the benefit of it as a user in front. But it's everywhere. It's absolutely everywhere in the world. And I think the graph, I'm talking as a database people, I think that's the next challenge, making it seamless, making it like, okay, graph can be everywhere where they are needed, and you don't need to fill it, but you will get the result out of it. And whether that means, in healthcare, whether that means for document processing, for legal, for whatever industry, but where it's needed, you just will have it easily. And I think it's the challenge there. It comes with scalability and other things, but that's my 2 cents on that front.
All right. Remy, do you have anything to say, or we can have our first question from Alexia?
I think I join Adam's opinion, and I would, as a CTO, basically like graph databases to be better and better and as good as our colleagues in the relational domain have been doing amazing things since then.
All right, perfect. Alexia, I'll quickly unmute you. You now have the permission to unmute yourself and you can ask your question.
Hi, everyone. Thank you for the discussion today. I really found it very informational, and I'm glad that we got to touch a bit of the theoretical components of context graphs and that whole debate between like where it's going to go in the public eye and also how we're seeing it as developers. This is more of like a thought experiment, so I guess you guys can take it away and see where it goes from here. But I was just thinking about maybe what you have to say about how context is dependent on hallucination, because hallucination comes into play and when we're running AI models, and then that often will get stored into knowledge from, I guess, like a high level perspective of the architecture. So my question is, what do you think of the existence of a node for hallucination specifically that is active only on either the storage or the production of the hallucination, be it that it's given by the user or that it's produced by the LLM, but it's incapable of being activated for recall, where the node is like either being stored at a different weight or scale than general knowledge would be. So if everything is sitting in the same general knowledge graph, something like hallucination, if we're saying that we don't have context graphs because they're just going to be like a hot word, and we only have knowledge graphs that there's some type of tag or label for hallucinations, and that hallucinations can only be something that are stored but not retrieved, and they are only something that is labeled, but they don't produce new knowledge. They only add to context, and they can't be retrieved out of context. They can just be filed as a contextually dependent node of the graph. And the reason why I'm asking this is because, well, I'll let that sit. I'm not sure if that was understandable. So just some head shakes would be appreciated if my question. Okay.
Yeah, good. I think.
May I ask one question back to Alexia?
Yes.
So,
yeah, of course.
How you define hallucination then?
Hallucination, I didn't want to really throw in the realm of like fact and fiction, because I think fact can also be disputed very easily. But I would take it from like a cognitive science standpoint on the the issue that humans are easily persuaded via sycophancy. So, and that is something that AI produces a lot of. And as humans, we're able to differentiate between what is real versus what is hallucination by being able to directly engage with it and seeing outputs. We're very dependent on the immediate output. Even if we think about like how we're studying quantum, for example, it's what we see as the instance that we've just observed. So the hallucination, I think in this context is like it's both unobservable because it has zero audit trail. It can't be traced back to any former knowledge because it's based on pure confabulation. It didn't come from anything substantive. So that's my context. Sorry, it's a bit busy here. And yeah, I guess that's my question. So what do you guys think about that?
I think, I mean, in theory, that would be interesting to have that label, either as a node or label or whatever on those informations. You could also but the key problem is detecting the hallucination. So who knows and defines what's the hallucination and labels it and links it to that node? So if you have a human in the loop, then okay, they could link it. Then my second worry would be, okay, if you let it go into the context, we know how LLMs can drift very easily. So if that hallucination is fed, it will be taken in the loop of the LLM and just keep being fed constantly. So you would need to have a really well thought out design, unless if it's more of a, playing on the cognitive aspect, etc., and wanting to test things is something different, I would say, where you want to use the hallucination, because some people are actually using hallucination to try to do creative discoveries. Or as Jochen just said, if 1,000 people could say it's an hallucination, but it is not, like if 1,000 people are wrong, doesn't mean they're right. 1,000 people could think that the hallucination saying the earth is flat because the LLM read some weird documents. We may be in trouble. So it's very difficult to manage, to be very frank. I hope.
All right, thank you so much, Alexia. Hope that answers your. Oh wait, you can unmute. Wait. Let me see if I can find you. All right. In the meantime, I'll let Lavanya ask. Okay. Thank you so much, Alexia. In the meantime, I'll let Lavanya ask your question.
Hi, Dorek. Thanks. Thanks for the opportunity. My question has been lingering for the past many months about data modeling. Before the LLMs, as a data modeler, as a cipher writer in Neo4j, I felt the importance of modeling well creates good queries. So now my question is, in the wake of AI, how important it is to model the graph well? I mean, the directionality and everything. I think it all needs to be learned by LLM. So I think the data model has to be good, but I'm trying to see if there is some parts that LLM can ignore, even if the data model is not great, like naming issues or whatever, but still depend on how good the model is. Sorry, I don't know if I framed it correctly, but I think the role of data modeling, graph data modeling in the wake of AI is my question.
Yeah, just as kind of the simple answer from my side. If the LLM doesn't understand the data model, it will hallucinate to try to understand it. So then it's kind of a root problem of why you can't create the very strict context. So that's simple like that. So yes, there is a kind of the curve where the growing of the graph and complexity of the graph will just falling into that it's becoming ununderstandable by the LLMs or even by the humans. So, but that's a mastering of it. We have to work on this and keep it on the level when we can have that the semantical model is stable, when all the relations, labels, and whatever are representing exactly what you have in mind when you're just talking with the LLM and trying to reduce the hallucination by providing their factual context. Yeah.
All right. I hope that answers the question. And we had a couple questions in the chat as well. Let's do one last question, and then we can wrap things up. Wait, I'm trying to get a question. Krishna said you can reduce hallucination. Yeah. Yeah. So Richard asked if there are any recommended readings, any recommended books. Apparently he's new to the topic of graphs and knowledge graphs. So any recommended books for people to get more into the space?
Go to the Graph Geeks community. They have a lot of good books there, and actually Amy Odler, who's one of the founders there, she also released a really good book on knowledge graph and graph analytics and so on.
Yeah, we do recommend everything by Amy Odler.
Right.
And I will mention the book from the Jim Weber and the Joseph Barras from the Neofuji, but their book about the practical of knowledge graph is very good as a beginning of understanding what the practicality of that.
Oh yeah, actually Visal has a question. Do you want to raise your hand and I can unmute you if you want to ask it, or I can read your question, which is a bit long. Let's see. All right, Richard says thank you. You're welcome. Okay, Visal. All right. Okay, you should be able to unmute yourself now.
Yeah.
Visal?
Yep. Can you hear me?
Yep.
Yep. Hi. Yep. Thank you for this great discussion. I also wanted to ask you, like, it seems like in most of the use cases so far, the graphs are being used as more of a way to discover relevant context or knowledge and then retrieve this information through those relationships and give it to the LLMs. So basically RAG, but in a more advanced relational way, right? Is that covering all of the use cases that you guys are using graphs for right now, or is there ever a use case where you have wanted to maybe find the relevant subgraph in your graph and give the subgraph directly into an LLM while keeping it as a graph? Because the problem right now is LLMs still can't natively take in graphs as graphs. So we've like experimented with multiple ways of textualizing this graph, but graphs don't really convert into text well. So the quality degrades a lot. Graphs are very interconnected by nature, and text isn't. So it's like hard to represent a graph in its full fidelity as text. So yeah, has there ever been a case where you've wanted to ingest a part of a graph as a graph into an LLM?
Yeah.
Yes. I think, Adam, you want to talk about our work regarding drug repurposing and using drugs for different cases.
Yeah, exactly. I think like typically we've done it actually quite a few times. So either extracting a subgraph or path of a graph or a set of paths that links actually end up being a subgraph, So for example, you may have multiple drugs that go to a target, sorry. So you have multiple paths and it ends up being a small subgraph. Okay, so this typically a few ways to feed it to the LLM. We found is you can test it. Sorry, I'm getting tired. Test it with the text format. It's absolutely possible, but yeah, indeed, you may lose some aspects. Otherwise, we found that stuff like JSON structures, for example, work quite well actually to pass on the information of the graph to LLM because it's structure. It still keeps a certain structure. It's textual, but it understands JSON. So you can then use this subgraph in different contexts with the LLM, query it. So meaning okay, could you tell me whether that drug hits that target or not? And the thing there is that you need to play a lot with your context and prompt engineering, do back and forth and so on to make it work. But you can do things, but there is no systematic way so far to do it. It seems. Yeah, Visha.
I see. Okay. Yeah, thank you for that. I had one follow-up, a smaller one. So like right now, I guess it depends on the structure of the graph, but if your graph is more star-shaped, where then you have this central node and then all the other nodes around it are basically representing some aspect or information about this central node, then all the paths leading out of the central node, like each path represents like a different information about this node, right? In that case, it's like quite hard in the sense that you basically want all the paths going out of the central node to capture that node fully, and not just one or two different paths going out. Or you might have like, because it's a star graph, you don't model the paths between these or the interconnections between these different paths going out of the central node. In that case, does it then come down to the design and structure of the graph itself?
I have a comment on that, because there's a discussion about the star graph models, and there is always kind of their practical implementations where we see it's fine when you model it, you have the central graph and they're modeled one, but when you start growing, you're finding that there is a different aspects, and their discussions running if that model is relevant to the real world. Is it have this central node or kind of overloaded node with information can be represented as a different ones in the temporal way, in the property way. So if I see the star model on the graph, I will also thinking it's not complete. So
Okay, I see.
it's kind of my practicing takeaway. So, but Adam and Remy can just give their experience.
I agree. It's that's exactly where you would start working with labels, because you are missing something in the dynamic. So in biology, for example, everything is linked to ATP in the metabolism. Doesn't mean every disease is linked to ATP. It's just that it's the most connected node. So it ends up like, very quickly taking over your analysis. But if you start playing with labels, you start thinking, okay, like at this time, at this spot, like does these nodes and those connections still make sense? And you can use the label filtering to start working and making it a way more lean graph. And it ends up not being a massive connected nodes actually quite quickly sometimes.
Correct.
I see. Thank
All
you.
right. Let's wrap up. We've actually been a bit over time, but that's all right. Thank you all for joining. It's been a great session. We will have more industry-focused sessions in the upcoming weeks. We'll announce them very soon. But thank you all for joining, and yeah, see you guys next time.